for the evaluation of definite integrals, we have gone through a topic, and that was evaluation of a definite integral by limit as a sum. And in the limit as a sum, in the introduction part, we have gone through such type of a graph. Now, second method for evaluating definite integral is fundamental theorem of calculus. Okay. So now let's discuss fundamental theorem of calculus first with the help of this graph, which we have already done it. Now, when we have introduced this graphical part for the definite integrals, how it was defined? Let me repeat it. We have defined integration for a to b fx dx, a to b fx dx, this part from a to b fx dx as the area of the region bounded by the curve, as the area of the region bounded by the curve y is equal to fx, with the ordinates with ordinate. Now, what are the ordinates here? X is equal to a. Ordinates are x is equal to a and x is equal to b, and x-axis itself, and x-axis. X is equal to a, x is equal to b, and x is equal, and x-axis means this line x-axis and the ordinates this a and this b. This x is something different. Okay. Now, the ordinates a and b, a up to here, and this is the graph. This is the graph starting from here, going to up to this thing. A graph, infinite graph, but the ordinates a and b, from a line parallel to y-axis, from b a line parallel to y-axis. Okay. So, this we have already done it, that this was the area, and when we are evaluating it by the limit of a sum, we were getting the results. Now, basically what it is, now let's define it in the more sophisticated way. Now, let x, now it is this x, okay, let x be a point, let x be a point on x-axis in a comma b. X be a point in a comma b, and it is naturally it is on the x-axis. Then now if I am writing a to x fx dx, a to x, earlier it was a to b, from here to here a to b. Now I have written from a to x fx dx represents the area shaded in red. Means what it is representing? It is representing starting from here up to here, this part and this part. These are the four parts from where we are representing a to x. This one, it is of now this part like this. This is a, this is x, and these are the 2 points on the curves. So, this basically this represents area. If I am writing a to x fx dx represents the area shaded in red, and if I am writing x to b, now if I am writing x to b fx dx, now what this represents? This represents area in green, area in green. A to x fx dx represents area in red, x to b fx dx represents area in green. Okay. So, now the area in red shade the area in red shade or the red shaded region, the red shaded region is a function of x represented by capital AX. I have already written here A capital AX, and this is the area represented by capital AX. Then what we can write it? Then we can write it capital AX is equal to A to x fx dx. Is it clear? So first thing, for the fundamental theorem of calculus, first basic thing was, if we are having these types of a graph, then how to represent, how to find the area when ordinates are given. Okay, so a to x and x to b. Now this should be very much clear what I have explained. Okay, now we will be going for the theorem parts.